In 8.6, we're going to integrate some integrals that are based on the derivatives of some of the inverse trig functions. So we're going to integrate integrals of these three forms. The first one is based on the derivative of arcsine, and the second arctan, and the third arcsecant. So let's look at this first integral, all right, and compare it to those three forms once again. Let's look at that. Okay, so here we have the three forms, and this one looks the most like this first form. All right, and in this case we have 25 is a squared, so a would be 5, and u squared is 16x squared. All right, so let me move this down a little bit. Okay. Okay, so we would say that this is a squared, all right, or this is 5 squared, so a is 5, and 16x squared, that's u squared, so that is actually 4x squared, so u is 4x. So let's just rewrite this. We can rewrite this as 1 over the square root of, and here we have 5 squared minus 4x squared dx. So here we have our a from this form, and 4x, that's our u. U is equal to 4x. So now we're going to do a u substitution to get this to look like this. Okay, so we're going to put u equal to 4x, and so du is 4 dx, and 1/4 du is equal to dx. All right, let's do our substitution now, and we have this integral is equal to, for dx, we're going to substitute 1/4 du, and we have 1 over the square root. Okay, we still have that 5 squared, that's our a squared, minus u squared. And now we know what this is equal to. Okay, looking at this form again, we're going to have a 1/4 in front, and then this is exactly of this form, so this will be equal to arcsine u over 5 plus c. And now just write what u is equal to. So we have 1/4 arcsine 4x over 5 plus c. In number 2, we have an integral that's of this form, and here our a squared is equal to 16, so we're going to write a is equal to 4, and u is equal to x. Okay, so once again, looking at this second form, we just simply use that as a guide to write down what this integral is equal to. So this is equal to 1 over a, that would be 1 over 4 arctan u over a. U is the same as x in this case. U over a, x over 4 plus c. Well, actually we have limits of integration here, so we're going to just substitute in now. All right, let's substitute in. So we have arctan 4 over 4, that's arctan 1, minus 1/4 arctan minus 4 over 4, that's arctan minus 1. Remember, the range of arctan is between pi over 2 and minus pi over 2. The angle whose tangent is 1 is 45 degrees, that's pi over 4. So here we have 1/4 times pi over 4, minus 1/4, and the angle within our range, whose tangent is -1, that would be minus pi over 4. So we have 1/4, we have pi over 16 plus pi over 16, which is 2 pi over 16, or pi over 8. We can see that number 3 is of this third form, okay, because of this x on the outside, and here we have u on the outside. So this is an arcsecant integral. Okay. All right, so first of all, let's rewrite it so that it's closer to this form. We want to have something squared minus something squared under the parentheses. All right, so that would be, instead of 9x squared, we're going to write 3x in parentheses squared. So 3x is our u, that's our u squared, and 16 is 4 squared, so let's write that. So 4 is our a. So we have u is 3x and 4 is a. So we're going to do a substitution. Let's do a u substitution. U is equal to 3x. Okay, so here we'll put u equal to 3x, and du is equal to 3dx, or 1/3 du is equal to dx. Okay, so let's start our substitution. So instead of dx, we're going to write 1/3 du. So that's instead of dx. And here we have 1 over, okay, now what is x? Well, x is 1/3 du. Sorry, 1/3 u. All right, so u is equal to 3x. And what we could do, well, let's just write x is equal to 1/3 u. All right, so instead of this x, we're going to put 1/3. We're going to put 1/3 u. All right, now underneath the square root, 3x is excuse me, 3x is u. So here we have u squared minus 4 squared. All right, so let's see. These actually cancel. This 1/3 is like in the numerator, and this one's in the denominator. These actually cancel. So let me just rewrite that without those 1/3. So we have 1 over u square root u squared minus 4 squared du. This is exactly of that third form. Let's look at that again. So here we have that third form, and this is exactly of that third form. A is 4, so let's just integrate according to this. So here we have 1 over a, we have 1 over 4 arcsecant. Absolute value of u is 3x, absolute value, well, let me just write absolute value of u over a over 4 plus c, and now we'll substitute u is equal to 4x. So finally, it's 1/4 arcsecant absolute value of, u is equal to 3x, absolute value of 3x over 4 plus c. In number 4, we have a hint that we should complete the square, and if we do complete the square, we'll see that we will get something that's of the form of an arctan integral. All right, so let's do that. So we'll complete that square in the denominator. So here we have x squared plus 4x, and we're going to take half the middle term, which is 2, square it, and we get 4. So we're going to add 4. But we can't just add 4, we also have to subtract 4. All right, in order not to change anything. And then here we have a perfect square, so let's write that as something squared, as it's actually x plus 2 squared. And here we have minus 4 plus 8, that's plus 4. Okay, so this is our integral, and now this is of the form of the arctan form. All right, our u is equal to x plus 2, and here we have 2 squared, so a is equal to 2. So we could just write this one more time. Let's write it as x plus 2 squared plus 2 squared dx. Now we could replace x plus 2 with u, although it's not really necessary because the derivative of x, because du would be actually equal to dx, so no constant would come out. So I think we'll just go straight to the, we'll just go ahead and integrate this. And we'll integrate according to the second form. Okay, so here we have the second form, and we have 1 over a here. This is a is 2. So here we have 1 over 2, arctangent, u is x plus 2 over a is 2, plus c. Number 5 is also closest to an arctan. All right, let's write this as in the denominator something squared, so that would be x cubed squared. Instead of x to the 6th, I want to write something squared, so that's x cubed squared, plus instead of 16, I'll write 4 squared. So this is going to be my a, and I hope it makes sense that this should be our u equal to x cubed, and it only makes sense if the derivative of u is within the integrand, which it is. The derivative of u is 3x squared, and we have an x squared over here, so that's good. So we can do a u substitution and end up with something like this. So we're going to do that. We're going to put u equal to x cubed, and du is equal to 3x squared dx, or 1/3 du is equal to x squared dx. So let's start substituting. Instead of x squared dx, we're going to put 1/3 du, and here we have our u squared and a squared, which is 4 squared. So we have something exactly of this form, and we can now go ahead and integrate. So I'll just put that 1/3 in front. Here we have 1 over a, so in our case that's 1 over 4. Arctan u is equal to x cubed over a, and a is 4, plus c.